Thank you very much for waiting. We would like to start the next presentation. The speaker is Mr. Ito. He graduated from the special school, high school of the technology at Akita and joined the printing machine company. He was involved in the manufacturing industry and at a company where the measurement device was developed. He spent 10 years developing embedded software. With the boom of IT, he wanted to work in a software area, and a part of the company that his father operated, he get space to do the software department in the construction company, and now the company is moving forward, the software company, and developing the software for the control of the manufacturing industry, and also develop application for iOS as well. He's going to talk about the Ladder drive of IoT in the manufacturing industry. Thank you. I'm Ito from Ito Software Designing Company. Today, I would like to talk about the gem, which is called the Ladder drive. I would like to start from my introduction. Probably some of you are not familiar with the manufacturing industry, so I would like to talk about the manufacturing industry and followed by the presentation on the Ladder drive. Now, introduce myself. I was born in Daisen City, Akita Prefecture. Very famous for fireworks, and every month there is a festival of firework. Particularly Omagari is quite famous, and you can enjoy the splendid fireworks. Please visit if you have opportunity. And Kinu Musume is the brand name of the rice, Japanese rice, quite delicious. And also Daisen is the place for Akita Komachi. And edamame is quite famous at the Daisen City. So you may be eating edamame or Akita Komachi rice somewhere. And the following, the course is already introduced. I'm doing the software for the manufacturing equipment control and iOS applications. As a community, I operate Akita.m. This is for the web and the software information exchanges. And last September, we celebrated the 9th year Akita Ruby meeting. This is a kind of study meeting, and at this moment its activity is interrupted. Probably you might have heard what I made, a unit test and a Ruby Kaigi. A unit test is the framework of iOS, and safety is quite mainstream. At this moment it is not useful, but in the initial stage, as a iOS framework, a unit test was used. Ruby Kaigi. This is iOS application to view the conference. This is unofficial until 2013. It has been used since 2009 to 2013. Now, moving on to manufacturing industry. Simply put, manufacturing industry, but there are a variety of the sectors. I'm involved in one of those red circled area, particularly electronic parts and components were the area. And based upon that experience, I'd like to talk about this. Now, the programming for manufacturing industry, how it's made. Hopefully I could show you some machine for which I have the controlling devices, but usually there's some TV program in which you can see the plant tour of the manufacturing industry. So please remember, if you have seen those TV programs to understand what I'm going to say more easily. Now, PLC, a control equipment is used. It's also called a sequencer. This is the replacement of the relay circuits when it was developed. You see the example in the pictures. First, we have the main unit of CPU with a lot of slots. Depending upon the different device, you would add the extension modules. Now I mentioned the relay circuits. Simply, this is the lamp is lit with on, and with off, the lamp is unlit. So that is on the left-hand side of the on-off control. This is quite a simple control, but we need a relay. Just a switch and lamp do not complete this system. And when it's transferred to PLC, the switch and lamp will be connected to IO module, input-output module, and then the ladder chart is used. So how to connect these will be represented in the ladder chart. Therefore, the making the ladder chart means programming. And actually, you use AND and OR put into the schematic view, and this is logical and operation. So this is a system to continuously do the logical operation. And the calculation switches and the lamps are called the device. For instance, only for input, only for output, and also the internal coil represent the relay, and also data, which is responsible for the numerical values X, Y, M. You use these prefix to show the functionality of each device, and internally they are deployed as memories. And this is a 16-bit device internally, and switching on and off the bit device is represented in 1 bit of word device. In doing the control, you provide the meaning to each device, and information from the device will be obtained, and to see the status of the operation, and also you see the presence and absence of the problems, and also the information of the thermal status. Now, how to get the device information? Now you use a telecommunication module. First, both serials and Ethernet would enable communication. And in the communication module is embedded with a protocol. Depending upon the embedded protocol, you can do the telecommunication and obtain information. Now, as example of the usage, for instance, there's a touch panel on the manufacturing equipment, that the instrumental panel. In place of the physical switching, you use the switch visible on the surface of the touch panel to provide instruction. So this is the device, the virtual device on the touch panel, and then you can perform the transmission of the data, and also the temperature is locked, and the information is stored in the data logger. And there's IR board, that is iOS application, and actually this can be done through iPad. The switches and touch panel on the equipment is fixed, but by using the iPad, it is possible to communicate a bit far away from the actual machine in the manufacturing factory. Now I'd like to move on to ladder drive. Ladder drive is a package of GEM. As I explained, this is with a function of the communication with a PLC. That's virtual PLC. Therefore, it also has a function of the emulator, in which there's a device data space. And the Ladder drive, the first I came up with this idea, actually PLC differ from one company to another. It's difficult to standardize, or it's not common. Therefore, if you use a PLC of a company A, then you have to use the tool of a company A to do the programming. In the case of a PLC of the company B, you need to use the tool of company B to enable the programming. Therefore, they are discrete. I wanted to have a common virtual PLC for different types of a PLC. This was a kind of experiment. In PLC, you make a virtual PLC. It's like a firmware, the virtual PLC within PLC, and you can communicate with a virtual PLC and use exactly the same ladder data, and you don't have to worry about the differences of the PLC by different company. For instance, company A and company B, I demonstrated the possibility of a communication between company A's PLC and that of company B. I almost finished this endeavor, but the manufacturing industry wanted to introduce IoT, and I had an opportunity to get involved in IoT, so I experimentally used the Ladder drive to make a contribution of IoT activities of manufacturing industry. So that's IoT Hub. Now, first of all, we need to get data from manufacturing facility and equipment. And there is the data space in the device of the virtual PLC, and I try to collect all of the data in the virtual PLC. And bringing the data from PLC, we can use usual telecommunication. So that is a function of the Ladder drive, which is effectively used to collect information from the PLC. And then next is embodiment implementation. This is basically the emulator of a PLC. So I decided to use a plugin for extension, and I made a system for the extension, and the conditions of the telecommunication will be done using the conditions setting files. That is a PLC underbar mapper underbar plugin .rb, and PLC, which part of the PLC would be deployed to which part of virtual PLC. Data correspondences are set first, and then if you use a plugin, then the communication is enabled, and then the data would be deployed. So you obtain the data, and after that, where do you transmit the data for further utilization? Now, actually, we send it to cloud. Actually, what to monitor differ from one company to another. If you have the specific purpose system, you cannot use it for other companies. And therefore, you need to make a specific purpose the products. And that is why we are moving so slowly. And you can use a Sinatra and Rails, and you can come up with idea. But actually, the PLC engineers do not have such a knowledge. Therefore, even a system is developed, then the PLC engineers do not know how to make full use of it. And so that's how I decided to come to web service. So manufacturing people want the IoT to notify the abnormality and also visualization of the operational status, what is the problem, and what are the possibility of improvement. They wanted to make a good decision. And if something happens, they want to have the traceability to secure the quality. If something happens, they want to trace back to the original cause of the problem. So if you want to use a web service to solve these problems, what kind of service can you use? The notification of the abnormality, oftentimes people use IFT, if the plugin was made to get connected, and API keys were set as well, and in which occasion, which was timing, what should be sent. So this is example of the abnormality of the temperature, and you get something happens with the excursion of the temperature, you see it. The next visualization.
So sometimes we would like to see what is the situation of the system in a graphical presentation. So we may be able to utilize ambient system, and ambient underbar plugin is to be used. And again, this is the setting for the API use and what kind of information or data should be sent at what timing is systemized. And sometimes we would like to make it presented in a Kanban way or the plate ways, and this is a Trello utilization. The machine is now on the hold, and the other side of the plate shows that another equipment is on operation. The quality is another thing we have to look at, and Slack can be used. And Slack plugin was developed. And it is similar to what I have explained. And there is UR to make an access to Slack, and we decide what kind of data should be sent at what timing. And there are some comments to be added, because device underbar comment is a symbol, and we can see what is happening. And we use the keyword of Slack underbar webhook, and we would send an information on the events we encountered. And that's the schematic diagram showing the relationship of what I have explained. So there is a ladder drive offering the data space, and plugin allowed information collection from multiple PLC, because we originally planned to use it in the manufacturing industry. But if we can make multiple plugins, we may be able to collect data from sensors. Through plugin, we may be able to read and monitor the data available in the data space, and we can send it to cloud service so that we can realize IoT. What kind of data is to be used and what timing the data should be sent can be customized. Now I would like to show you the demonstration. I don't know whether it works or not. I'm not confident. And there are some errors here as represented on the graph. And if we implement it, virtual PLC is to be started. And at the bottom, we can have an IR board, and this serves as a touch panel. And the system has been in operation before I started my presentation, and it is 58 degrees of centigrade. This is the temperature. And that's how we can make a representation in a graphical format as shown on the left panel. This is a trail. And the lamp is on, showing that machine A starts to operate. It was on the hold, but it was switched to the operation mode, and label is given, and the green shows that the equipment is in operation. When it is stopped, it would turn to the previous color, known color, just black and white. So that's how we visualize the system operation of the equipment. I think I will not be successful here, but if there is an abnormality observed, sorry, it is not reflected in the lamp, but abnormality was detected, and it was noticed on the screen. And at the logging button, we can record temperatures. So one Slack allows everything, data collection and the notification of the events. And if maybe there might be some problems with this. Maybe the time is not correct, so there might be some problems with the communication, but if there is some abnormality detected, the notification is to be made. Going back to my slide, this is the summary slide. So we first made virtual PLC for demonstration studies, but it seemed that it could be used for IoT. So plug-in function was added, and because of that added plug-in function, we can collect data in the shared memory, and it is not only those data related to PLC. We can have some data from the sensor as well, and we may be able to send the data to the web services, and we can customize by changing the file at the setting. And now we have several, but if we increase the number of protocol, the usability would increase. And also the setting files have been developed with my own desire, but it can be further refined so that we can use those files in a shared environment. Thank you very much for your kind attention. Thank you very much, Mr. Ito, for your presentation. I would like to entertain questions from the floor. Any questions? If you have questions, please raise your hand. Yes, please. The person in the front row, please. Thank you very much for your wonderful presentation. My question is the following. In your talk, you talked about the touch panel on the equipment, and you can make it in the format of iPad so that it can be a portable system. If it is made into an iPad, and if we can carry it, there might be an operator who might be away from the equipment, resulting in some danger or some accidents at the the production site. Yes, you're right. So there is the possibility So Bluetooth signal should be caught. So this iPad can be used only when the Bluetooth signal is reachable. So we can set where they can carry those iPad to. Thank you. Any other questions? No questions? Then thank you very much, Mr. Ito. And if you have further questions or some topics to share with him, please do it afterwards individually. Thank you very much.